3.3 continued. The product rule, the quotient rule, and higher order derivatives. So in my last video, you guys wrote down the sum and difference rule, which simply states that if you are taking the sum, if you have a sum of two functions and you are taking the derivative of those two functions, then all it is the derivative of each function individually. Okay, and the same thing goes if you're subtracting, if it's a difference of two functions. The derivative is still just the derivative of each function individually. That does not apply for the product of two functions. Okay, so here we have the product rule. So if we have two functions, let's call them f and g, okay, and they are being multiplied into product, then the derivative is the derivative of f times the g function plus f, the f function, times the derivative of g. So in simpler words, let's say we have two functions u and v. It's the derivative of the first function times the second function plus the first function times the derivative of the v function. Okay, I'll show you guys some examples in a bit so that this can make more sense. But there is also a quotient rule. So taking the derivative of a quotient is not as simple as taking the derivative of the top function times the derivative of the bottom function. It's not that simple. What you have to do is follow this quotient rule. So once you take the derivative of, let's say, f of x over g of x, it's the derivative of the top function f times the bottom function g minus the derivative of the bottom function g times the top function f, all of it over the bottom function g of x squared. Or again, in simpler words, u over v is just u prime v minus uv prime over v squared. Okay, so let's look at some examples. So let's go ahead and find the derivative of this function, f of x equals x squared plus 1 times x cubed plus 3. So here we have two functions. We have the f of x and the g of x. Okay, but let's go ahead and use u and v. So in my experience of teaching this calculus class, I've noticed a lot of students like the simple uv notation better. So I said that the derivative of u times v is the derivative of the first one times the second function plus the first function times the derivative of the second function. So we apply it here. F prime of x is pretty much x squared plus 1 prime. So the derivative of x squared plus 1 times x cubed plus 3. There's no prime on that one. We're not taking the derivative of that. Plus, now we leave the first function x squared plus 1 alone. We are not taking the derivative of that. Times the derivative of the second function. So that one's prime. Okay, so here's my u function. There it is, x squared plus 1. Here's my u function. There it is, x squared plus 1. And my v function is x cubed plus 3. Okay, now what we got to do is we got to take the derivative of the prime ones. So this one becomes 2x plus 0. Right? We learned the power rule in the last video also. So we take the 2 to the front, there it is, and subtract 2 from 1 on the exponent, or subtract 1 from 2 on the exponent, and you got 1. The derivative of a constant 1 is 0. So here we leave this one alone, x cubed plus 3. Okay, then we leave x squared plus 1 alone. And then here we're going to do the same thing. We're going to bring the 3 to the front. We're going to use the power rule. And then subtract 1 from that 3 to make it squared, plus the 0, because the derivative of 3 is 0. So this is where we're at now. So we get 2x times x cubed plus 3 plus, we can put the x, or the 3x squared up before the x squared plus 1. Okay, this is a good answer. We can leave it here, or we can keep taking it further. Distribute 2x to the 4 plus 6x plus 3x to the 4 plus 3x squared. And then combine like terms. That should be 5x to the 4 plus 3x squared plus 6x. That's your answer. Although this answer would be okay too. Alright, now let's look at an example that requires the quotient rule. So f of x is equal to x squared minus 1 over x squared plus 1. Here the u is x squared minus 1. The v is x squared plus 1. Quick reminder on the quotient rule. I want you guys to notice that the top looks a lot like the product rule, with the exception of the sign, the operation. Instead of it being a plus, it's a minus. And the denominator is the exact same denominator of your original function, just squared. So f prime of x will be, so let me use some highlighters to highlight this. So we have x squared. Let me use a different color. Let's see. X squared minus 1 is u. And then x squared plus 1 is a v. So what we have is x squared minus 1 prime times x squared plus 1 minus x squared minus 1 times x squared plus 1 prime, all of it over x squared plus 1 squared. Alright, so this one, x squared minus 1 prime becomes 2x. This one, x squared plus 1 prime also becomes 2x. It's just the derivative of x squared minus 1 is 2x. The derivative of x squared plus 1 is also 2x. So f prime of x is equal to 2x times x squared plus 1 minus 2x times x squared minus 1, all of it over x squared plus 1 squared. Go ahead and distribute. 2x cubed, 2x plus 2x. Now this negative 2x, this minus 2x applies to both of these, so minus 2x cubed plus 2x over x squared plus 1 squared. Now this thing will happen. 2x cubed minus 2x cubed will cancel each other out, and we are left with 4x over x squared plus 1 squared. That's the answer. Now go ahead and write this note. If the numerator or denominator is a constant, then do not use the quotient rule. Here's why. The derivative of 3 over x to the fifth, we can easily rewrite that as the derivative of 3x to the negative 5. All that is using rules from my last video. So if you bring that negative 5 to the front, and then you subtract 1 from that negative 5, you'll get a negative 6. Keeping in mind that I can multiply this constant 3 to the derivative, so that's negative 15x to negative 6. Okay? X to the 7 over 5 could be viewed as 1/5 x to the 7, and we just apply the power rule. Keeping in mind that we're taking the derivative of x to the 7 and multiplying 1/5 to that derivative at the very end. And we get 7 over 5 x to the 6. Okay, the last thing I want to hit is higher order derivatives. So the second derivative is denoted by y double prime or d squared y over dx squared or f double prime. The third derivative is denoted by y triple prime or d cubed y over dx cubed or f triple prime x, and so on. That pattern continues. Let's look at this quick example. So find the first 4 derivatives of y equals x cubed minus 5x squared plus 2. The first one is y prime, and that's just applying the power rule to each of these. 3x squared minus 10x plus 0. Notice I can start doing this a lot faster now. The second derivative is y double prime. So we can do this in our head. We're going to bring that down. The 3 times the 2 will be a 6x. Now, taking the derivative of x is just 1. So negative 10 times 1. 0 is just 0. It's not even there anymore. The third derivative is just 6. And then finally the fourth derivative is 0 because the derivative of a constant is 0. That's all.